Hey guys, how you doing? We are using this kind of as a test format for our Calculus 1 course for the rest of the semester. So this is going to be me walking you through the last spec we had in class, which was the tangent line and velocity spec. And so you'll have a recording of how to solve this spec along with what it looks like. So the first problem on this specification quiz was finding a line tangent to the curve that's given, finding the equation for it. And so there are three steps we do in this. The first step is you want to find the slope of the tangent line. And we find the slope by finding the derivative. Y prime is, this is a product, right? So we do a product rule. And so we do the derivative of the first, which is 2x plus 0 times the second, plus the first, x squared plus 1, times the derivative of the second, the derivative of e to the x minus 1 is itself, times the derivative of the exponent, but the derivative of x minus 1 is just 1, so it doesn't really do anything. And so therefore, to find the slope of the tangent line, we are looking when x is equal to 1. And so we plug a 1 in where the x is everywhere. And that's going to be nice because when we plug it into the e, 1 minus 1 is 0, and e to the 0 is 1. And so we get 2 e to the 0 plus another 2 e to the 0, and that's just 4. 2 plus 2 is 4. And so that's the slope. So that's the first step in finding the equation for the line tangent to the curve. And then what we need to do is, let's give us a little bit more room here. We need to find the point involved. And if you want to find the point when x equals 1, we plug it into the original y, and that gives us y equals 1 squared plus 1 e to the 1 minus 1. So we get 2 e to the 0, which is just 2, and so we get the point 1, 2. So we have this point, we have this slope, and so finally we're able to use the point slope formula, which gives us y minus y1, 2, equals m for x minus x1, 1, and I'm fine with that. Or if you wanted to solve for y, you distribute the x and get 4x minus 4, add a 2 to that, and you get 4x minus 2. And so the equation of the tangent line, I would have accepted either one of those. Basically, this is a 2-point problem. The first point would be given for finding the slope of 4, and the second point would be for everything else. Okay, so that is how you do problems 1 and 2, finding the equation of the line tangent to the given curve. The second problem here, problem number 3, says using a linear approximation. Remember, that just means find a tangent line and use it. And so here's your function you're finding the tangent line for, and you're going to find it at a equal 4. 4 obviously is a very close value to 4.1, and the square root of 4 works nicely, and so that's why we picked 4. All right, but again, it was all given to you. And so the first step here is to find the tangent line once again. In order to do that, we need the derivative. And if you want to find the derivative of this, it's a lot easier if we think of this as 2x to the minus 1/2. Square root is 1/2 power. It's in the denominator. So the derivative of that is 2 times negative 1/2 x to the negative 3/2. This reduces and becomes negative 1 x to the negative 3/2, or minus 1 over x to the 3/2. And again, you probably need to think of that as the square root of x cubed. Same thing, but easier to evaluate. And so when we come down here to find the slope, that's f prime at the point 4. And so that's negative 1 over the square root of 4 cubed. 4 cubed is 64, and so we get negative 1 over 8 as our slope. Continuing with this process, we know that f of 4 is 2 over the square root of 2. Sorry, 2 over the square root of 4. And that's 2 over 2, which is 1. So that's your point. And so if we come down here now, we get y equals, y minus y1, excuse me, equals m times x minus x1. And so y is our tangent line, 1/8 x minus 4 over 8, which is 1/2, plus 1, so we get plus 1/2. I'll let you figure out the algebra there. So we get y equals 1 over 8x plus 1/2. But of course we want to approximate. What are we approximating? We're approximating this value right here, 2 over the square root of 4.1, which means we're approximating this function here when x is equal to 4.1. So we are approximating it with the tangent line. This is the tangent line right here. Here's your tangent line. Your y value is approximating f of x, and so we can say f of 4.1 is approximately 1 over 8 times 4.1 plus 1/2. And at this point, it is certainly fine to use the calculator. The calculator will allow you to find this approximation value directly and precisely. We're not going to plug the 4.1 into the original function in our calculator. That's not what we're doing. We're plugging 4.1 into this function. So you get 1 divided by 8 times 4.1 plus 1/2. And that turns out to be the value of 1.0125, and that's your approximation value. All right, we didn't have to find an error, so this is the answer that I was looking for from you. Okay? Now, on to the last page here. Problem number 4 says find the acceleration of the ball at time t equal 2, and you're given that the particle is moving at sign. So I guess particle, to be fair, this should not say ball. I don't know where that came from, but it should say particle. Same idea. To find the acceleration, you first have to find the velocity, which is s prime. And so that derivative of sine is cosine of pi t, but we do need a pi, right, when we take that derivative because of the chain rule. And then to find the acceleration, that's the derivative of velocity, and the derivative of cosine is negative sine of pi t times pi, but then of course we already had a pi from here. And so we get negative pi squared sine of pi t. So if you want to find the acceleration at time equal to 2, you get negative pi squared sine of pi times 2, but 2 pi, the sine of 2 pi is 0. So you get a 0 for the whole thing, but this is still feet per second squared. You need a unit when you're dealing with particle acceleration or velocity. Finally, for the last problem here, once again, we want to find velocity because a particle is at rest. It's not moving. What does that mean? That means v of t is equal to 0. So the velocity here is found using the product rule, and you've got the chain rule involved with that. So the derivative of the first, you bring down the 2, 3t minus 4 to the first times the derivative of the stuff inside is 3. And then, of course, that's multiplied by the second, 2t squared to the third, 2t plus 1 to the third, excuse me, plus the first times the derivative of the second, and the derivative of the second uses the similar chain rule. You bring down the 3, 2t plus 1 all squared times the derivative of the stuff inside, which is 2. Now, this is horrible, right? This is a big ugly mess, and if you try to multiply this all out, you'll never get anywhere. So what we do is we look at the common factors of the 3t minus 4 and the 2t plus 1. We also have a common factor of 6. If you notice, the 3 and the 2 is in common to both. And so we can pull out the 6. We can also pull out one of the 3t minus 4s. Right? This is power of 1, this is power of 2. And so we pull out one of them. This guy has two 2t plus 1s, and this one has 3, and so we pull out two of them. And then, of course, we've gotten rid of these 2 times 3s. And so what are you left with? You're only left with a 2t plus 1 here, and you're left with a 3t minus 4 here, and of course they're added to each other. And so we're going to set the velocity here equal to 0. Let me get rid of that mess there. There we go. All right, so we want to set this equal to 0. So we have 3t minus 4 is equal to 0. And we have 2t plus 1 is equal to 0. And then we have this thing, which if you put them together, you get 5t, and you get a minus 3, and that's equal to 0. So remember, you can't set things equal to 0 unless you're factored and multiplied. It's called the zero product property, not the zero sum property, and so you have to have a product before you can break them up. So if you solve this first one for t, take the 4 to the other side, divide by 3, you'll get 4 equals 4 thirds. T equals 4 thirds. Here you'll get t equals negative a half. And here you'll get t equals 3/5. But remember, t is time. And you are given in the problem that time is greater than or equal to 0. And so that means that this second answer we got to get rid of. So we're actually left with only 2 times. You're not given a unit in this case. It does not say what the units of t are. And so you just have 2 options for your value for t. You get t equals 4 thirds and t equals 3/5. You needed to get both of these and not include the 1/2, negative 1/2. You needed to find it, but not include it. Okay. So anyway, that is how you solve the problems from the tangent line spec. Tangent line, velocity, acceleration, and also linear approximation. Lots of stuff on that particular spec. And so anyway, that's the deal. And hopefully that helped a little bit. And that gives you an insight into kind of how we're going to try to be conducting class moving forward. So I'll post this, and if you guys have questions on it, you can always email me with those. I'll be posting a video soon giving you an update on how class is going to work and how our grading scale might change a little bit and how specs are going to work moving forward. Okay? Thanks a lot, and we'll talk to you soon.